Okay, so we've got the third root of 24, x to the 5th, y to the 9th, and z to the 13th.
Yes.
Okay, you're looking at each piece individually. So you're looking at your 24, your x, your y, and your z, all individually to do the third root. 24 is not a perfect cube, so I can't just take the third root of 24. But I can break 24 down to two numbers that multiply to be 24, where one of them is a perfect cube. 3, what? Not 3. Nope, 6 and 4, neither one are perfect cubes. 8 and 3. Which one's the perfect cube in 8 and 3? 8. What's the cube root of 8? 2. So I can bring my 2 out to the front. And then my 3 has to stay in the house. Okay, so the non-perfect has to stay in the house. Then I'm going to break up my x to the 5th to what? X to the what power? X cubed. So I can do an x cubed and I can do an x squared. So what can come out? X cubed, just one of them. So I'm just going to put an x out here. And what am I leaving in the house? X squared. Okay, then I have y to the 9th. So I'm going to break that up to y cubed, y cubed, y cubed. What am I taking out? Y cubed. I can take out 3 of them. And then I have z to the 13th. So I have z cubed, there's 6 of them, 9, 12, and 1 left over. So what am I putting on the outside here? 4, z to the 4th. And I'm leaving in just the z. So today, what we're doing to add on to what we've already done is we're going to multiply and divide radical expressions. So we're going to multiply or divide to get here. Actually, today's just multiplying. We're going to multiply to get here, and then we're going to have to do what we did yesterday to get here. So you're going to have to know how to simplify radicals to get there. I did look ahead. This chapter is super long, and last year I split it up. This year I'm going to split it up to 2 tests, so you don't have a whole bunch of stuff on one test. So we're just going to do the radical stuff first, up to 6-4. So 6-1 to 6-1, 6-2, and 6-4. And
So is it going to be like 2 short tests?
No, it'll be 2 regular tests. So it looks like though it falls on the Tuesday after we get back from that 4-day weekend.
So in like April?
No, not Easter. The next week is parent-teacher conferences. We have Friday and then Monday off. So that Tuesday. Yeah, I made it shorter, so I was just going to test you in April.
Well, that's all.
Not Easter.
Why do we have that Monday? What Monday do we have off?
President's Day.
We have President's Day off.
February 17th. Well, it just happens that you've always had it off, but it's a professional development for teachers. So we have Friday.
President's Day off? Really?
Since I've been here. Well, I take that back. For that's about 5 years since you've been here, up here. Okay, so let's start. Grab some notes for 6.2. And actually, I'm gonna. Well, we'll get a calculator for the last example. So this is 6.2. We're going to multiply radicals. And here's what you need to know about multiplying radicals. Multiplication rules are the same as just multiplying anything. So you can multiply x times x to get x squared. You can multiply a y times a y. You can multiply z times z, and you can multiply numbers together. But what you have to be able to multiply radicals is the same root. So like if I wanted to do the third root of something times the fourth root of something, I cannot multiply those two things together. It has to be the same root with both of them. And if you have the same root, what happens is whatever's on the inside you can multiply together, and whatever's on the outside you can multiply together. Just like if it was just regular old multiplication. So, and here's the math version of that. If I have the nth root of A times the nth root of B, I can multiply that together to get the nth root of A times B. So you just multiply together what's on the inside, if you have the same root. And if you were to have numbers on the outside, you just multiply the numbers on the outside together also. So inside stays together, outside stays together until we go to simplify. So your first of two examples, because I want you to have practice time today, is going to be the third root of 9x times the third root of 6x to the fourth. Okay? So, first question you ask yourself is, do you have the same roots?
Yeah.
The answer is yes. It's the third root. And we're having to retrain our brain to be the third root. And if you have the same root, then you just look at, okay, I'm going to multiply the number parts together. They're both in the radical. So what's 9 times 6? What? I heard all kinds of stuff.
63.
54. My goodness. I think I heard a 56. I heard a 63. I think I heard a 64 or 54, I hope. Okay?
I heard someone say 63.
What's x, of course, what's x times x to the fourth? S to the fifth. Okay, so now you've done everything that's new today. You've multiplied underneath the radical to come up with something that looks like yesterday's stuff. So now we start with what we learned yesterday, and we have to simplify that radical. So 54, we have to think of 54 breaking down to two numbers where one of them is a perfect cube. So in your head, you've got a 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Do any of these divide into 54?
Yeah, 27.
27. So we get 27 times what is 54? 2. Okay? 27 is a perfect cube. So what's the cubed root of 27? 3?
Or 8. Yeah, 3.
I don't know. So 3 comes out of the house. Oops, I should have left a little room. And what stays in the house? What did you do? 2. So now we have to break our x to the fifth up to what? What and what? X squared and what else?
X cubed.
X cubed. What can come out of the house?
X cubed.
Okay, what's the cubed root of x cubed?
X.
X. And what stays in the house? X squared. So this is your answer. So everything, this new stuff we did took us 2 seconds. The stuff from yesterday is what you guys need to practice, I think.
Yeah.
Yeah. It does.
Yeah. Okay, you guys grab a calculator. We're going to work through this next one. So everybody get their calculator, please. No,
Joe, I have to use my phone, right?
no, you need to go grab one out of Mrs. Tronic's room. Actually, there's somebody missing today, so just grab theirs.
Hey, Drew.
Miller, you're right next to them. No.
Hey, you guys stop. Just simmer down. Here's your next problem. I want you to take a minute. You don't need your calculator for this part. You're going to combine the two together. Then you're going to, I only got to let you use your calculator just because sometimes the numbers are hard to figure out what you can take out. So I want you to get used to using that resource because it makes it a little easier for you. So for this example, we're doing the square root, which is nice because that's how our brain works, is a square root. But I also want to show you how to do the cubed root on the calculator. So you have the square root of 72 x to the third y squared times the square root of 10 xy cubed. Okay, so everybody write this down and put this together. So what do I have for my number part? What's 72 times 10? 720. And then x to the what power?
Fourth.
Fourth. y to the 5th, right?
Yep.
Okay. Here's what you're going to want your calculator for. When you get real big numbers, square root's easier, but especially when you get real big numbers in cubed root, because our brain doesn't work real well with cubed root. We're looking for two numbers that multiply to give me 72 or 720, where one of them is a perfect square. And you want to try to find the biggest one of those you can. So you're going to, in your calculator, start dividing 720 by perfect squares. So example of a perfect square is 1, 4, 9, 16, 25. And I'm going to tell you the highest one that you can take out of that is bigger than all of those. So start dividing by the perfect squares that you know and see what you can take out of there. And I bet, I'm going to guess, you guys find different numbers, and that's okay. So, okay, do it on your own.
I think it's 100.
What did you just say?
You said
Okay.
it.
I need to respond.
Oh, found it.
Actually, 13 once you go.
Okay. Somebody give me one pair that they got. Actually, I want to start with one I heard. 36 and 20. Okay? Who all got 36 and 20? Okay. That's a good starting point, but that's not the ending point, because when you have 720 and you have 36 and 20, which one's the perfect square? 36. 6 comes out to the front, but you're left with the square root of 20 that has a perfect square in it. It's okay to start here, but you have to keep going if these are the pairs you chose, because this 20 has 4 and 5 in it. The square root of 4 is what? 2. So that comes out, and you now have a 12 on the outside times the square root of 5. Okay? And that's okay. If those are the two you chose, that's okay, because you just need to keep going. What's another pair that people chose?
144 and 5.
Okay, 144. If I have 144 and 5, what's the square root of 144?
12.
12. And what's left in the house?
5.
5. So this is what I call a one-stepper. If you get at the big enough, or like the biggest perfect square in it, you only do it with one step. It's okay, though, if you go 2 steps. Okay, just make sure when you get to this point, you look at this number and say, is there a perfect square still in that number? If there is, you need to take it out. Okay, so let's just continue with this. X to the 4th power, how many of those can you take out? 2. So you should have x squared. Let's keep doing this today.
That was neat.
Just on this area of the board. So we have an x squared on the outside. Y to the 5th, we can break that down to y squared, and y first. So I have a y squared and a y on the inside. So this should be your answer no matter what path you took to simplify the number part. Okay? Okay, last thing I'm going to show you. If you hit the math button, math is right below alpha. You'll see number 4 down looks like a cubed root. So if you wanted a cubed root number, you just go down to 4, hit enter, and then type in your number. So like if I type in 27, I'll get 3. So that's how you do the cubed root. Let's say I want to do the 4th root, the 5th root, or anything higher than the 3rd root. You have to first type in the number of the root that you want to do. So let's say we want to do the 4th root. I'm going to type in a 4. Go back to math. Look at the one right below the cubed root, and you'll see one that looks like this. It's got a little x. That means any root. So I go down to 5. And then let's put 16 in. And it should come up with 2.
I'm confused about how you did that.
Okay, listen, and I'll tell you one more time.
Almost.
Hit the 4,
Just the number?
the number 4.
Okay.
Hit math.
Math.
Scroll down to the one right below the cubed root.
Okay.
Hit enter one time.
Got it.
Type in the number and hit enter.
I was still hitting the fourth one where I had the cube.
Oh, yeah, no, you want the one right below it. The X means any root. So, okay. So here's the homework I want you to do. And I want it quiet in here because the simplifying stuff, some people are here, they've got it. I've got a lot of people that are here, they're not. So I want it quiet in here so everybody has a quiet room to practice in. And I would like to go over this in class if we can. Because tomorrow, I'm not going to be here. 371, 10 through 24, I don't know. Does it bother anybody else that my go over is always right next to each other? It looks like Goober. Yeah. I had another teacher come in